Hey, what if I told you most large language model evaluations you see online are actually misleading? And even worse, they might be giving you false confidence about your system. So, today we're going to look into a paper on large language model evaluations from Google that actually tries to address this and fix this. So, welcome to the series on decoding papers with AI, where we use AI tools to quickly decode papers and try to get a full understanding of what the paper is about. So let's jump right in. So the paper is titled A Practical Guide for Evaluating Large Language Models and LLM Reliant Systems. And these are co-authored by authors from Google. So as always, we're going to use Saral AI to decode this paper. So I already uploaded this paper here just to save on time. And as always, I'm going to click on one click podcast to give me a quick podcast of this whole paper. So this is going to take a little while, so we'll come back after this is complete, right? So the podcast is now complete, so let's go and see what's going on.
Hey Rohan, ready to dive into this LLM evaluation paper? Looks meaty.
Absolutely, Aisha. A practical guide for evaluating LLMs sounds crucial given how fast things are moving.
Right? So many LLMs, so many claims. How do we really know what's good?
Exactly. This paper highlights that synthetic benchmarks aren't cutting it anymore.
Synthetic benchmarks, like those standardized tests for LLM.
Precisely. They argue real world scenarios have a distinct set of challenges.
Makes sense. A chatbot answering customer queries is different from, say, writing poetry.
Totally. And the paper proposes a framework for practical evaluation. 3 pillars, right?
Datasets, metrics, and methodology. Let's start with datasets.
Okay, they emphasize representative and high quality data. The 5 Ds.
The 5Ds. Defined scope, demonstrative of production usage.
Diverse, decontaminated, and dynamic. Quite a mouthful, but it makes sense.
Decontaminated, that's about avoiding overlap with the training data, isn't it?
Yup. So the LLM isn't just regurgitating what it already knows, prevents inflated scores.
And dynamic means the dataset evolves as the LLM and its use case change, right?
Exactly. It's a living body of work. Love that phrasing.
So, how do we actually get these amazing datasets? The paper mentions 3 approaches.
Benchmarks, human annotated golden datasets, and synthetically generated silver datasets.
Benchmarks, those are the existing, publicly available ones.
Right. They're a good starting point, but often too generic, the paper says.
And potentially contaminated. Plus, licensing issues, always a headache.
Golden datasets are the ideal, I guess, human experts providing high quality examples.
But super expensive and time consuming, right? Finding those experts
And ensuring consistency between. Then there are the silver datasets, synthetically generated.
LLMs creating data to evaluate other LLMs sounds a bit circular, doesn't it?
It does, but they emphasize.
So just been going through the paper a little bit now, at least getting some idea about it. So one interesting fact is that in order to evaluate LLMs and LLM-based applications, I think what from the podcast it's trying to say is that you need 3 things: data sets, metrics, and methodology. So I'm well aware of what data sets and metrics are. Methodology, it'll be interesting to see what it tries to say there. And one thing that is interesting is that I think just to make these operationally good and easy to follow, I think they are in terms of data sets, they have like divided that into like 5 Ds. One is like I think it says defined scope, demonstrative of production usage, diverse data sets, decontaminated, meaning it is distinct from any data used in the training set, and dynamic, treated as a living body of work that evolves as real world application changes. So I think they just try to fit the 5 Ds here, but it's sometimes when you work in these types of systems, it's always these help in like kind of quickly remembering what how to like go about things, right? And then I think so. Therefore, I think a good amount of the paper is about the data sets. So this is about the golden data sets and then the silver data sets, which are like supposedly like synthetic. Golden data sets are the ones which are human verified, and these are supposed to be really good. And a few more from here is what I see. And let's see what more the podcast says, right? It's a small podcast, so
Eyes careful human oversight to avoid bias and contamination.
So, using a powerful LLM to generate data, but then having humans check it?
Precisely. They mention constitutional AI where the model self-critiques.
Self-critiques? Interesting. Like the LLM judges its own responses?
Based on a set of predefined principles. Helps guide the generation process.
Okay, that's datasets covered. Now, on to the second pillar, metrics. What makes a good metric?
So I think it basically stopped here. It didn't go beyond the datasets part, but at least like it's good to see that at least a little bit of some portion of the paper was covered at this. So let's go further dive and see what more is in this paper. So to further know what's happening in this paper, I'm going to shift to NotebookLM, and so I already uploaded this paper onto NotebookLM, and I'm going to try a couple of formats here. So first one, what I want to try for myself is this is called the mind map. So given a paper, you can quickly like get a mind map of what is going on. So it says that this is the paper. It's divided the paper into like 5 parts. And the first part is evaluation framework pillars, then dataset curation, evaluation metrics, real world challenges, and implementation steps. So let's go into each one of these and try to figure out what more you can find out. So the evaluation framework, as we saw before, has 3 parts: the datasets, the metrics, and methodologies. And datasets can further be divided into like, so here they use the 5 Ds, but I think they missed 1 D when they're defining it. So it's like the scope, the usage, how diverse the data set is, decontaminated, meaning that it's not part of the training set, and then dynamic. I forgot what dynamic was, but I think you can check it out in a while, or let me do it right away. So dynamic meant somewhere it was here, right? So the dynamic meant the data set should be kept current, implementing a process to regularly audit, update, and version. Okay, that's okay. So it's basically the data set is current, and maybe change it as relevant and if needed. So then the metrics are quantitative versus qualitative, term overlap, semantic similarity, then a few other entailment. I don't know what NLI is. Then autorators. So I think autorators are like LLM as a judge. Basically, LLM is going to judge its own thing. So that's the other thing. And then if you go to methodology, it has handling non-determinism, prompt sensitivity, hallucination, and component evaluation. So I know what hallucination is. The other 3 things I'm not that familiar with. So let's first. So, and then if you go to data set curation, it talks about public benchmarks, human annotated. Okay, now it talks about the data set parts, right? Human annotated golden data set and synthetic silver data sets, and then metadata tag. And then evaluation metrics, it's divided into overlap metrics and model based. So overlap metrics are the ones I think based on some similarity scores, things like Rouge, Blue, and Meteor. I don't know exactly what these are, but maybe you'll figure it out if needed, if you from the paper. And okay, so these are also similarities. So cosine similarity, perplexity, and self-consistency. So the only one that I'm familiar with is cosine similarity, and the other one's not fully familiar, but yeah. And then real-world challenges include stochastic computation, sensitivity, grounding versus prior knowledge, undesirable non-responses. And so these are some of the ways in which like you kind of try to see whether it's you sometimes, for example, it may still give a response, but it's not really what you desire. It may not be a wrong answer, but it not be the right answer either. So things like that. So implementation steps: define objectives, sample size, statistical hypothesis testing, analysis, and iteration. So overall, it's good. I don't think I understood everything here, but it's still a decent thing. I would say I would rate good content. So let's close this, right? So now we are done with mind map of the paper. So I also want to do an explainer video. So we're already like done the explainer video. So it is generated a 6-minute explainer video. So let's put it to full screen and see what it says about this paper. So this is going to be the last part, which we can do a few more formats, but just I've just finished with this and try to see how much it can make me understand this paper.
Okay, so large language models, or LLMs, they're pretty much everywhere now, right? And they are getting unbelievably powerful. But that power creates a huge new problem. How in the world do we know if we can actually trust them? Let's break down how you test the mind of a machine. I mean, these systems can be just mind-blowing. 1 minute they're poetry, the next they're debugging your code or planning out your entire family vacation. It really can feel like magic. But, and this is a huge but, here's the flip side. That exact same AI can also hallucinate, and that just means it invents stuff, confidently making up facts out of thin air. It can be brilliant 1 second and then just completely spectacularly wrong the next. And that gets us to the real heart of the issue. If you're going to build something that depends on an LLM, how do you make sure it's reliable? How do you make sure it's accurate and safe for people to use? You can't just throw it out there and hope for the best. That's not how it works. You need a structured scientific game plan for evaluation, a way to actually measure its performance framework for this. It takes this super complex process and breaks it down into 3 main pillars. So think of it like this. First, you need the right test questions. That's your data sets. Second, you need a fair grading system. Those are your metrics. And third, you need to run the exam properly, and that's all about your methodology. All right, let's dive.
So I like this. All of this information we saw before, I like the way in which it divided, Become as explaining and divided it into 3 parts, right? The 3 pillars, the data sets, and then the metrics, and then the methodology as well. So that's nice to kind of relate to.
So if you're going to test an AI, you first need a really, really good set of exam questions. But what exactly makes a test question good in this context? Well, a great dataset follows what we can call the 5 Ds. First, it's got to be defined. You need to know what you're testing for. Is it a medical AI or a creative writing AI? The test has to match. Next, it has to be demonstrative of what real people will actually ask it. It also has to be diverse, covering lots of different topics and difficulty levels. Now, this next one, decontaminated, is absolutely critical. You have to make sure the AI hasn't already seen the answers in its training data. Otherwise, you're not testing how it thinks, you're just testing its memory. And finally, the dataset has to be dynamic, because let's face it, the world is always changing. So where do these test questions come from? Well, you basically have 2 options. You can create what's called golden data, which is meticulously crafted by human experts. It's the best quality for sure, but man, is it slow and expensive to create. The other option is to use another AI to generate silver data. It's super fast, you can make a ton of it, but you gotta be careful, because it might just reflect the biases of the AI that made it.
Well, I really like the previous illustration, how, again, it's about how we can relate to things, and it opens up bulbs in the different parts of our brain, right? So even before, and even as part of the paper, we had seen this golden data sets, human annotated golden data sets, which are really good. And then synthetically generated silver data sets, which are kind of okay, but still it's not bad, kind of. And then what's so nice about this illustration here is that you can see this crown jewel kind of setting. And you can see how humans are creating this golden data sets from this hand, right? Which implies there's a human involved. And then they're also saying it's slow. They put up a snail. I would say it's supposed to be an AI. So the AI put up a snail here to indicate it's slow. And then it's also expensive. So there's also a dollar sign here, right? So it's an interesting part. And then you have here that they're indicating it to be some kind of a robot, but it's also not directly a robot. So it's kind of a machine which keeps generating these silver data sets. And then they try to indicate it via like another machine which is collecting them, kind of, and you have these silver data. So here, another critical point is that there's only one golden data point, right? Whereas here, it's possibly cheap. They didn't indicate it as cheap, but you could generate many of them synthetically. Like quickly, you can generate a large set, right? So that's the other one. So the illustration is truly, I know I've been saying it almost for different papers, but it's the truth, right? You have to accept it. And it's absolutely, amazing. Amazing is not, amazing is too easy, a simpler word. It's the astounding or phenomenal. So let's go on.
Biases of the AI that made it. Okay, so you've got your test questions locked in. What's next? Well, you need a way to grade the answers. And that brings us right to pillar 2, metrics. How do you actually score what the AI says? A really common way to start is, well, it's pretty simple. You just see if the AI's answer uses the same words as the correct answer. But as you're about to see, that can go wrong fast. Let me show you. So check this out. We asked the AI to summarize the Apollo 11 mission. We have our golden reference, the perfect answer. Then we get 2 responses. Candidate A is just wrong. It says they landed on Mars. But candidate B is factually correct. It just uses different words, like main goal instead of primary purpose, and moon rocks instead of lunar samples. And here is where it gets absolutely wild. When we use a simple word matching metric, believe it or not, the completely wrong answer, candidate A, actually gets a higher score. Why? Because it copied more of the exact phrases from the prompt, even though the main fact was dead wrong. Meanwhile, the correct answer gets a lower score just for using synonyms. I mean, this just perfectly illustrates the trap, right? A good way to grade these things has to understand meaning. It can't just be about counting words. And that's where smarter metrics come in. Things like semantic similarity, which checks if the meaning is close, or natural language inference, which is kind of like a built-in fact checker that looks for contradictions. You can even use another powerful AI to act as a judge, an auto rater, to score things like fluency or factuality. Okay, so we've got great questions and a smart grading system. We're done, right? Not so fast. You still need to have the right rules for the exam itself. And that's our third and final pillar, methodology. One of the biggest headaches here is something.
So one more thing I like about so far this whole illustration is that we know that it's going to be LLM evaluations, and you need data sets and you need evaluation metrics. So that's like when somebody reads the paper, it's definitely you understand that part. So no issues there, right? What is nice in this NotebookLM's illustration is that it's kind of changed or transferred this problem and to relate to a problem of like writing an examination. And for an examination, you have like, say, test questions and test answers. And then you have these metrics or which is supposed to like, say, grade them, right? And now an exam can also have rules, right? Like in the sense that, is it a multiple choice question, or is it true or false, and stuff like that. And those rules constitute the methodology. So that's another amazing illustration, is that it's kind of transferred this problem to a different sphere. So it's easily relatable to a human because we all know about exams and so on. So it's a minor detail, but it's definitely worth appreciating.
Called non-determinism. Basically, it means you can give an LLM the exact same prompt twice and get 2 totally different answers. So how are you supposed to test something that keeps changing its mind? Well, there's a pretty clever workaround called self-consistency. What you do is you ask the same question, let's say 10 times, and then you just take the answer that comes up the most often. It's like taking a majority vote to figure out a delicate balancing act. See, to stop the AI from making things up, you can tell it, hey, if you don't know, just say, I don't know. But if you make that rule too strict, the AI gets overly cautious and starts refusing to answer questions it actually can answer. It's a constant trade-off between being safe and being helpful. So there you have it, our 3 pillars: the right datasets, the right metrics, and the right methodology. But the work doesn't just stop when the test is over. If we look back at our framework, you'll see it's not a straight line, it's a loop. The results from your test feed back into the beginning. You analyze what went right and what went wrong, and you use that to improve your datasets, your method, and of course, the AI itself. And that continuous cycle, that's the whole game right there. It's the invisible engine that's driving all this progress, making these incredible tools better, more useful, and ultimately more worthy of our trust. Which, of course, leaves us with one last kind of mind-bending question. These AI systems isn't just about testing the AI we have now, but about inventing the tests for the AI that's coming next.
It's busy. So it's also stopped with a question, something thought-provoking, so that it's not just summarizing his paper, also leaves out of the question. So as always, this is an amazing illustration. So definitely, I learned a lot more from this. So to conclude, so this was a really great illustration on this paper about LLM evaluations. And these AI tools definitely laid some kind of a foundation on what the paper is about and what it's trying to convey. And definitely when I read the paper now, it's I could definitely relate to it in a much better way, and also understand what the paper is trying to convey. So hope you liked it, and until next time, catch up with the next paper.